Hi, in this video, we're going to review how to do a hypothesis test for two independent means. And this is one of the review videos, so it's really going more over problem-solving techniques than theory. So let me share my screen and start with the first problem. Okay, in this problem, it says Country Gardens magazine investigated two varieties of sunflowers, skyscraper sunflowers and American giant sunflowers. They grew many of each of the varieties, and they took a random sample of 32 skyscraper and 34 American giant. And so the mean and sample standard deviations in each variety are presented below in this table. And the question is, at the 5% significance level, do the data provide evidence that the mean height of the varieties of these two varieties differ? Okay. So I'm going to start off with just claiming that the first one we'll call group 1 and the second one we'll call group 2. Okay, so to start with, I have the formulas from your formula card reproduced over here. Okay, for two pool T test statistic for the null hypothesis that mu1 equals mu2, assuming equal population standard deviations. So this is the T statistic, and we're going to work here with the pooled standard deviation. So we're going to have to calculate the pooled standard deviation and then use it in the denominator as we calculate the T statistic. Okay. So as I said, we're going to call skyscraper will be group 1. And I'm going to call it 1 and 2 because I want to be able to follow along with the formulas, okay? And then American giant, we'll just call that group 2. So when we refer to the subscript 1, then we know we're talking about skyscraper. Okay. So the question was, at the 5% significance level, do the data provide evidence that the mean height of the two varieties differ? Okay, so let's go ahead and look at our first step in the hypothesis test. Is going to be the determination of the null and alternative hypothesis. So the null hypothesis is that mu1 equals mu2, and the alternative hypothesis, keyword differ, mu1 does not equal mu2. Okay. So normally we kind of pull out the important numbers in the problem and we identify them, but most of them are in the table. This is the X bar, that would be X bar 1 and X bar 2. This is S, that would be S1 and S2, and this is the N, N1 and N2. So the only thing that we have to remember is that alpha equals 0.05. That's the only piece we usually pull out before we get started with the whole 6-step hypothesis testing process. Okay, so step 2, the statement of the significance level, alpha equals 0.05. Step 3 is the calculation of the test statistic. So as I said, we're going to use the pooled standard deviation, right? Because in this case, these standard deviations, the larger divided by the smaller is less than 2. And so that means it's reasonable to assume that the underlying standard deviations are equal and we can pool them to get the SP. Okay, so let's jump in with the SP formula. One big square root n1 minus 1 times S1 squared and 2 minus 1 times S2 squared divided by N1 plus N2 over 2. So I'm going to substitute in. These are the two S's, S1 and S2. This is N1 and N2. N1 is 32, so N1 minus 1 is 31. S1 is 4.3. It's the first chunk. And then we get 34 minus 1, that's 33. Times 3.1 squared, and the whole thing gets divided by N1 plus N2 minus 2. Okay. So maybe take a moment, let's work, if you want to pause the video, work out the calculations. Okay, and I get the numerator is 890.36 and the denominator is 64. That gives me a square root of 13.91. And the pooled standard deviation is 3.73. So a pooled standard deviation must always be between the two standard deviations. So 3.7 is between 4.3 and 3.1. So that check, we passed that check and I've checked the calculations. So I know that that one is right. Okay, so now I'm going to calculate the T statistic using that pooled standard deviation SP. Okay, I'm substituting in X bar 1 is 13.2. X bar 2 is 14.1. SP 3.73. 1 over 32 plus 1 over 34. Okay, so again, perhaps pause, try to work out the calculations and then come on back. I get the numerator is negative 0.9 and the denominator 0.919. And when I divide it, I get a T statistic of negative 0.98. Okay, so step 4, we're going to be using the critical value approach because this is a T test. And that's what we're doing so that we can use our tables. Okay, so we're going to look at, this is a T with degrees of freedom equal, actually should have put that here, right? Degrees of freedom is N1 plus N2 minus 2. Okay, so in this case, 32 plus 34 minus 2, that's equal to 64. And it is two-tailed, so the rejection region has 2 parts to it. And the total area in the rejection region has to be equal to 0.05, and these 2 tails are equal. So each tail, 0.05 divided by 2, 0.025, and this one as well, 0.025. Okay, so I want to share my screen and go over, look at the formula card and the T table to get the critical values here. Okay, so you go to the last page, and this table is our T table, and we have 64 degrees of freedom. So we're here in this row, and we want the table to give us T, so 0.025. 0.025, 1.998. Okay. All right. So we get 1.998 as our critical value, and by symmetry, it's opposite on the to the left there. So this big region is the do not reject H naught region. And these two guys are our rejection region. So together they make 5%. That's the rejection region. Okay, great. So that's step 4. And in step 5, we want to determine if we want to take the test statistic and graph it on the graph from step 4. And that will help us determine if we should reject or do not reject the null hypothesis. So because our test statistic fell in the do not reject region, the decision is to do not reject the null hypothesis. And I'm going to write step 6 up here, the interpretation. At the 5% significance level, the data does not provide evidence to, because we did not reject the data, does not provide sufficient evidence to conclude, and this is what we want to conclude right here, that the mean heights are different. Population mean heights are different. Okay, let's take a moment and just review. Group 1 and group 2. The keyword was differs, so that's our alternative hypothesis. Significance level was given, and the strategy for calculation is calculate the pooled standard deviation and check that it's between the two standard deviations. Then calculate the T statistic. That's step 3. All that calculation of the test statistic. Step 4, find your rejection, non-rejection regions, right? And then step 5, plot your test statistic here to make your decision. Do not reject, and the interpretation. Okay. And now let's look at the next problem. Okay, so I'm going to go and let's look at the problem. I'm going to share my screen. Okay, so let's read this problem. A study was held in a pain management clinic to determine the effectiveness of mindfulness for reducing chronic pain. The study randomly assigned 60 patients into 2 groups. Group 1 received an additional program to guide and support patients in the use of mindfulness for reducing chronic pain. Group 2 was a control group. No additional program was offered to them. The results of the study are presented in the table below. So here we have group 1, which was the mindfulness group, and group 2, the control group. We're given the sample size, 30 in each group. And here we have a sample mean decrease in pain level. So we're decreasing pain, so large number implies more pain reduction, okay? So we have the sample means here and also the sample standard deviations. The question is, at the 10% significance level, do the data provide sufficient evidence that mindfulness is effective at reducing pain. Okay, so let's go to the whiteboard. Still have our formulas on, so we're going to use those again. And here's our basic data transferred already. And we're given, in this case, alpha is 10%, 0.1. Okay, so we're going to do the same. Oh, we probably should figure out the alternative hypothesis, right? So we know the null hypothesis is mu1 equals mu2. And I'm going to read again. At the 10% significance level, do the data provide evidence that the mindfulness is effective at reducing pain? So we want to know if group 1 had a larger reduction in pain. Okay, so that would be, is the reduction in group 1 greater than the reduction in group 2? Mu1 greater than mu2. Okay. So let's head in here and substitute in to our SP formula, and it is, and each of the samples was of size 30, so N1 minus 1 is 29. 0.9 squared, that's the standard deviation for group 1, plus 29 times 1.2 squared. I'm going to divide all of that by 30, plus 30 minus 2. Okay, maybe pause the video and try the calculations on your own, because I think with a little bit of practice, the SP is the sort of calculation that I see a lot of really effective, accurate calculations in SP, but it does take a couple of practice tries there. The numerator, I got 65.25, and the denominator inside that big square root was 58. And that is 1.06. Let's go and check. Is 1.06 between 0.9 and 1.2? It is. So let's go ahead. I'm going to move forward to substitute into the test statistic. T, x bar 1 minus x bar 2. 2.7 minus 2.1. And the denominator, we have the pooled standard deviation, 1/30 plus 1/30. Again, if you want, you can pause and come back and check your calculations. Pause now. Okay. So the numerator, I got 0.6, that difference. And the denominator 0.274. That gives me a T statistic of 2.19. All right. So now we need to work on step 4, which is the rejection, non-rejection region. So we're going to determine the rejection, non-rejection region. This is a T curve with N1 plus N2 minus 2 degrees of freedom. So that is 30 plus 30, 60 minus 2. So my degrees of freedom are 58. And we are one-tailed, right? So U1 greater than U2, it is a right tail greater than right tail test. So alpha is 0.1 or 10%. Now all of that area stays in this tail. This is a one-tail test, so we don't have to divide by 2 like we did in the first problem. We did that because it was a two-tail test, one-tail test. The whole alpha goes into the tail. Okay, so this is my rejection region. do not reject null hypothesis in this region. And so we have to go over to the formula card to find that critical value. Okay, we have 58 degrees of freedom. So that's the row you choose. And then the column 0.1. So it's 1.296. All right. Now my favorite part, you get to make a decision. So you take your test statistic from step 3. You're going to graph it on the graph over here. T is equal to 2.19. 2.19 is greater than the 1.296. So that means that the test statistic is in the rejection region. So the decision is to reject the null hypothesis. Okay, and for the final step, step 6, I'll write it up here because really we use the information from these guys here to help us write it. So at the 10% significance level, the data does provide evidence because we did reject. So the data does provide sufficient evidence to conclude that the pain reduction in the mindfulness group is greater than the pain reduction in the control group. And I'll just call that in group 1 is greater than. So this is a statement of this. Okay, so really the only way this second example differed from the first was that this was an example of a one-tail test. And to manage that, we kept, it was greater than, so it was a right tail. And we kept the entire alpha equals 0.1 area, significance level, all into that one tail. Other than that, it was pretty much the same process as the first problem. Okay, I hope this helps. I will see you soon. Let me know if you have any questions.